Welcome YouTubers to another episode in my Grammar Hero series. In this video, I'm going to discuss decimals, which have a very high likelihood of appearing in the arithmetic reasoning as well as the mathematics knowledge sections of the Armed Services Vocational Aptitude battery, that is the Asvab. Before I do that, however, I just want to take a few minutes to give you a high-level overview of the Asvab itself. First, I want to point out that the Asvab is nowadays a computer adaptive test for which you'll have 154 minutes to complete 145 questions. In addition to receiving a score for each of the Asvab's 10 subtests, you'll also receive what's called an AFQT score. AFQT, of course, stands for Armed Forces Qualification Test Score, and that's the score that says you're either qualified to join the military or not qualified to join the military. As you can see to the right here, your AFQT score is broken down in two different ways. It's broken down into categories, which range from 1 to 5, as well as percentile score ranges, which range from 99 to 1. The way this works, for example, is like this. If you score a 50 in terms of your AFQT percentile, that means you've scored better than 50% of all test takers, and at the same time, that would put you in corresponding category 3A. As a rule of thumb, you want to score in category 3 or higher. That is, you want to score somewhere between 31 and 99 on this test. Now you may be saying, I don't know anything about electronics information. Is that included in my AFQT score? Fortunately enough, it's not. Instead, the AFQT score is calculated based on your performance on the arithmetic reasoning subtest, the word knowledge subtest, the paragraph comprehension subtest, and the mathematics knowledge subtest. So my advice, as I like to say in every video I've made so far, is to devote the majority of your studying efforts to these 4 subtests, and in so doing, you'll raise your AFQT score and also qualify for the job you want in the military. Let me say this before we go ahead and get started with today's video. The hardest part of the Asvab is the fact that you're not allowed to use a calculator on it. So in other words, you have to do arithmetic, including addition, subtraction, multiplication, and division, including with decimals and fractions, by hand. Okay? So that said, let's go ahead and get started. Today's video, as I mentioned, is all about decimals, which are going to show up again on the arithmetic reasoning and mathematics knowledge subtest. So let's go ahead and make sure we know how to deal with those. Today's video, more specifically, is broken down into 4 different sections. In the first part, I'm going to talk about how you can convert fractions to decimals. Then I'm going to talk about how you can convert decimals to fractions. After that, I'm going to talk about how you add and subtract decimals. And then last, I'm going to talk about how you divide and multiply decimals. This says diving, should say dividing. Okay, sorry about that. Above all, I want to point out that many of you can do these first 3 things fairly easily already. That said, there are some tips I want to give you about multiplying and dividing decimals that should help you do very well on this test. So let's go ahead and get started. As you can see, we're going to talk about converting fractions to decimals first. As I mentioned in many of my videos, fractions are simply an expression of long division. That is, if I wrote 3 over 4, I can read that as 3 over 4 or 3 divided by 4. To convert a fraction to decimal, you read this the second way, 3 divided by 4. And in addition to reading it that way, you also carry out the operation of division. So 3 divided by 4 would look like this if we're going to do the division. And now we would actually work it out. Does 4 go into 3? It doesn't. 4 is too big, so we have to add a 0. When we add that 0, we have to bring a decimal place right here. Now the question is, does 4 go into 30? 4 times 7 is 28. 4 times 8 is 32, so we know this is going to be 7. As I said, 4 times 7 is 28. We subtract. 30 minus 28 is 2. We bring down an imaginary 0. Does 4 go into 20 evenly? It does 5 times. 5 times 4, of course, is 20, so we know there's no remainder. And now we know 3 over 4 is the same as 0.75. So again, we converted this fraction, 3 over 4, to the decimal, 0.75. Okay? Just via division. Let's try another one. So we get the concept. Let's do one that you don't see too often. Let's think about this. Let's do 14 over 28. Again, since we're converting fractions to decimals, we read this the second way, 14 divided by 28. So we're going to go ahead and do 14 divided by 28. And now we say to ourselves, does 28 go into 14? It doesn't. 28 is too big, so we have to add a 0 here. When we add that 0, we have to bring up the decimal. Now the question is, how many times does 28 go into 140? Now let's think about this. A big part of the Asvab is being able to use little shortcuts to estimate your answers. Let's say I made this 30 instead of 28, and I wanted to see how close I could get to 140 without going over. 30 times 5 would be 150. So let's go ahead and see if 28 times 5 will get us 140. So I'm going to work that off to the side. 28 times 5. 8 times 5, of course, is 40. Carry the 4. 2 times 5 is 10, plus 4 is 14. So we can see 28 times 5 will get us 140 with no remainder. So we know 14 over 28 is the equivalent of 0.5 or 1/2. Okay? So now that I've done 2 examples of that, I'm going to go ahead and move on to how you convert decimals to fractions. Again, fractions to decimals, just do the long division. 3 divided by 4, 14 divided by 28. You'll always get the correct decimal. Now let's talk about how to go the other way. That is from decimals to fractions. So to keep this video simple, I'm going to talk about 1-digit fractions, 2-digit fractions, and 3-digit fractions. So let's say I had this, and before I even get into that, let me write some number up here. Let's say I put 0.7531. That's just a random number I made up. This is your tens place. This is your hundreds place. This is your thousands place, and so on. Okay? So with this in mind, if I were to ask you to convert 0.7 to a decimal, I would first identify that 0.7, this 7, is in the tens place. So I'm basically going to put 7 over the place it's in. It's in the tens place. So 7 over 10. Okay? Now let's say I wanted to convert this to a fraction. Again, this 7 is in the tens place. This 5 is in the hundreds place. So I know I'm going to put this fraction over 100. More specifically, I'm going to put 0.7. I'm going to put 75 over 100. Okay? 3 digits, 0.753. Again, tens, hundreds, thousands place. So I know I'm going to put all of this over 1,000. Now, to get a smaller fraction from this one, for example, you could reduce or simplify the fraction. For example, I know 25 goes into 75 as well as 100. 75 divided by 25 is 3, and 100 divided by 25 is 4. Okay? So bear in mind that to get a decimal to a fraction, you find what place it's in, you put it over that tens place, and then you simplify. Okay? Let's see. We do have an example. Convert 62% into a fraction. So we got 0.62. That's 62%. To convert this to a fraction, we look at its places, tens, hundreds. So we know this is going to be over 100. And we're going to just throw 62 over 100. Now the problem we have is to reduce. To make things simple, I'm going to divide both top and bottom by 2 to start things out. 100 divided by 2 is 50. 62 divided by 2. 2 goes into 6. 3 times 2 times 3 times 2 is 6. Subtract. 6 minus 6 is 0. Drop down this 2. 2 goes into 2 one time. 1 times 2 is 2. Subtract, no remainder. So we know 62 divided by 2 is 31. 31 is a prime number, so we can't reduce this any further. So we know that the answer to this is 31 over 50. Again, 0.62, tens, hundreds, put it over the 100, and then simplify. Alright, adding and subtracting fractions is pretty straightforward. If you can add and subtract whole numbers, you do the same thing with fractions. So the most important thing you have to do is to line up your decimals, and that's it. So let's do this example. Add 3.147 and 148.392. 148.392. And we're adding 3.147 to it. Again, just line up your decimals and then add as you would for any integer. 7 plus 2 is 9. 9 plus 4 is 13, so we carry the 1. 3 plus 1 is 4, plus 1 is 5. Just drop down your decimal in place. 8 plus 3 is 11. Carry the 1. 4 plus 1 is 5. 1 plus 0 is 1. So 148.392 plus 3.147 is 151.539. Okay? Alright, now let's talk about multiplying decimals. Multiplying decimals is a little more tricky than adding decimals, in that what you do is you convert all the decimals to whole numbers, and then you simply add decimals back in at the end, which is what these three sentences say right here. Instead of reading those to you, let's go ahead and just do an example which I think will help the concept stick. So this says multiply 3.7 by 9.42. So let's go ahead and write this as we normally would. 9.42 times 3.7. And as I said, you convert these decimals to whole numbers by moving the decimal place to the right, and then you add the decimals back in at the end. So to make 9.42 into a whole number, I'm going to move this decimal place 1, 2 decimal places, and to make 3.7 into a whole number, I'm going to move this decimal place 1 time. So in total, I moved all the decimal places 3 Okay, I move 2 here and 1 here. So in reality, this problem becomes this: 942 times 37, albeit with 3 decimal places that we have to add back in at the end of this problem. So let's go ahead and work this out, and then we'll add the decimals back in. 2 times 7 is 14. Carry the 1. 7 times 4 is 28, plus 1 is 29. Carry the 2. 9 times 7 is 63, plus 2 is 65. Bring down a 0 since we're starting a new number. 2 times 3 is 6. 4 times 3 is 12. Carry the 1. 9 times 3 is 27, plus 1 is 28. Let's add. 0 plus 4 is 4. 9 plus 6 is 15. Carry the 1. 5 plus 2 is 7, plus 1 is 8. 6 plus 8 is 14. Carry the 1. 2 plus 1 is 3. We're not done. We have to add our 3 decimal places back in, so we'll go 1, 2, 3. So this is 34.854. Okay, again, make both decimals whole numbers. Keep track of how many decimal places you moved. Multiply the whole numbers and add those decimals back in at the end. Okay, and if you think about it, there's a way you can check this. Imagine if this was 10, if you rounded this to 10 and this to 4. 10 times 4 would be 40. Imagine if you rounded this down to 9. 9 times 3 would be 36. So, or 27. So we know our answer choice is going to be somewhere between 27 and 40, which it is. So logically speaking, we know our answer, our work's correct. Let's take a look at another example. 93% of 75 is. So this is basically saying 75 times 0.93. Okay. Again, as I mentioned above, we make this into a whole number by moving it 2 decimal places. So this becomes 75 times 93. At the end, we're going to add the 2 decimal places back in. 5 times 3 is 15. Carry the 1. 7 times 3 is 21. Plus 1 is 22. Add a 0 since we're starting with this 9 now. 9 times 5 is 45. Carry the 4. 9 times 7 is 63. Plus 4 is 67. Add. 5 plus 0 is 5. 2 plus 5 is 7. 7 plus 2 is 9. 6 plus 0 is 6. Add our 2 decimal places back in. 1, 2. So we know this is 69.75. Again, if you think about it, that's saying 69.75 over 75 is 93%. Okay? See if we have another example to do. We do. Penny makes $25.70 in tips on Wednesday, $32.30 in tips on Thursday, and $31.80 in tips on Friday. On Saturday, she spends 1/4 of the money on dinner with her friend. How much money does she have left? So over the course of 3 days, she made $25.70 plus $32.30 plus $31.80. Let's go ahead and add up those amounts. 0 plus 0 plus 0 is 0. Again, take care to keep your decimal lined up as best you can. 7 plus 3 is 10 plus 8 is 18. Carry the 1. Drop down your decimal in place. 5 plus 1 is 6. Plus 2 is 8. Plus 1 is 9. 3 plus 3 is 6, plus 2 is 8. So over the course of 3 days, she made $89.80 in tips. It says on Saturday she spent 1/4 of her money. So 1/4 is this, or 0.25. Again, you could have done 1 divided by 4 to get 0.25. And that's a bad 5, so let me fix that. So let's go ahead and find out what 25% of 89.80 is. 89.80 times 0.25. Again, as we just learned, to multiply decimals, again, we just added them. Now we're going to multiply them. We shift this decimal here twice, and we shift this decimal 1, 2 as well. So in total, we're moving 4 decimal places. So instead of being 89.80 times 0.25, the problem becomes 8,980 times 25, albeit with 4 decimal places to add back in. So let's go ahead and work this out. 5 times 0 is 0. 5 times 8 is 40. Carry the 4. 9 times 5 is 45. Plus 4 is 49. Carry the 4. 5 times 8 is 40. Plus 4 is 44. Let's add a 0 since we're starting this number. 2 times 0 is 0. 2 times 8 is 16. Carry the 1. 2 times 9 is 18. Plus 1 is 19. Carry the 1. 2 times 8 is 16. Plus 1 is 17. So let's go ahead and add. 0 plus 0 is 0. 0 plus 0 is 0. 9 plus 6 is 15. Carry the 1. 9 plus 4 is 13. Plus 1 is 14. Carry the 1. 7 plus 4 is 11. Plus 1 is 12. Carry the 1. 1 plus 1 is 2. Again, we have to add 4 decimal places back in. 1, 2, 3, 4. So we know that 25% of 89.80 is 22.45. Now, unfortunately, we're not done at this point because we want to find out how much money does she have left. So we're going to take 89.80 and subtract 22.45 from it. So if you think about it, this problem's done addition with decimals, multiplication with decimals, and subtraction with decimals. Okay? 0 minus 5 we cannot do, so we have to borrow a 1 here. This becomes 7. This becomes 10. 10 minus 5 is 5. 7 minus 4 is 3. 9 minus 2 is 7. 8 minus 2 is 6. So we can see that after she spent the money, a quarter of her money on Saturday, she had $67.35 left. Again, addition with decimals, multiplication with decimals, subtraction with decimals, and if you even wanted to, we can throw in, we had to convert a fraction to decimal. In case you didn't see that, let me go ahead and work that out for you very quickly. Again, we're reading this as 1 divided by 4, so we're going to do 1 divided by 4. 4 goes into 1, it doesn't, so we have to add a 0. When we add the 0, we say, does 4 go into 10? It does, 2 times. 4 times 2, of course, is 8. Subtract. 10 minus 8 is 2. Bring down an imaginary 0. 4 goes into 25 times. 5 times 4, of course, is 20, so there's no remainder, so we know that this is the equivalent of 0.25. Okay? So in this one problem, I've pretty much incorporated everything I've discussed so far. This one might do that as well. I think I chose it for that reason. Michael owns a consignment shop in which he earns 35% commission on all items he sells. If Michael had $8,434.80 worth of sales in the week, how much was his commission? So the first thing I want to deal with is making this into a decimal. That would be 0.35%. Okay. So what we're going to do is we're going to do 8,434.8. We're going to multiply that by 0.35 to find out how much his commission was. And as you can see, in order to do this one, we're going to have to multiply with decimals. So we're going to move this decimal place 1. We're going to move this decimal place 2 times. So this problem, if I rewrite it off to the side, becomes this. 83, if I can write it correctly, 8. Let me find, I'm just going to write it right under it since I don't want to run out of space. 8,434.8 times 35. And remember, we moved a total of 1 plus 2, 3 decimal places. So at the end, we'll add 3 decimal places back in from the right. Let's go ahead and work this out. Try not to rush when you get to this point. As you can see, we're multiplying fairly big numbers here. If you rush through this, you might make a mistake. 8 times 5 is 40. Carry the 4. 5 times 4 is 20, plus 4 is 24. Carry the 2. 3 times 5 is 15, plus 2 is 17. Carry the 1. 5 times 4 is 20, plus 1 is 21. Carry the 2. 5 times 4 is 8 times 5 is 40, plus 2 is 42. Since we're starting this 3, let's add a 0 down. 8 times 3 is 24. We're going to carry the 2. 4 times 3 is 12, plus 2 is 14. Carry the 1. 3 times 3 is 9, plus 1 is 10. Carry the 1. 4 times 3 is 12, plus 1 is 13. Carry the 1. 3 times 8 is 24, plus 1 is 25. Let's go ahead and add. 0 plus 0 is 0. 4 plus 4 is 8. 7 plus 4 is 11. Carry the 1. 1 plus 0 plus 1 is 2. 2 plus 3 is 5. 4 plus 5 is 9. 2 plus 0 is 2. Let's add our 3 decimals back in. 1, 2, 3. So we can see that this is going to be 2,952.18, which is right there. A lot of work, nothing too hard, as long as you know the tricks as to how to multiply decimals. Okay. So let's talk about dividing decimals. As was the case for multiplying decimals, it's simple, but you have to know the tricks to do it. In this case, what you want to do is you take the number that's outside the division, make that into a whole number, and then proceed accordingly. Alright, so let's go ahead and see what I'm talking about. So this says 7.42 divided by 0.7. So that looks like this. 7.42 divided by 0.7. So as I mentioned, you're going to take this decimal on the outside and move it once to make 0.77, which is a whole number. Now you basically mirror what you do on the outside to the inside. So this becomes you move this decimal place over 1. So this problem becomes 7 and 74.2. Again, you simply mirrored what you did on the outside. So before I go any further with this, let's just make sure that that's clear. Let's say I had this problem. Okay. Again, you cannot do long division with a decimal on the outside. In this case, I would have to move the decimal place twice to make that 25, and then I have to mirror what I do on the outside on the inside. So 1, 2. You might be saying, what do I do here? You simply add a 0, so this becomes 25, and this on the inside becomes this. Okay, let's just do one more to make sure we're all on board. Let's see, this was 0.01, and this was 12. Again, I have to move this decimal place 1, 2, and now I have to mirror what I do on the outside. On the inside, the decimal place is actually right here, so 1, 2. I'd actually have to add 2 zeros, so this would become 1 into 1200. Okay? Again, we can have something like this though. We can have 2 and 32.5. Since the decimal place is inside the bracket, we're not worried about it. If the decimal place was here, we'd be worried about it. But since it's not, we can actually work that problem out. So, getting back to this problem, let's go ahead and work it out. 7 does go into 7, but 7 goes into 74 10 times. And again, we're just going to bring this decimal straight up. It's right here in the bracket, so just bring it straight up above the bracket. 7 times 10, of course, is 70, so we're going to subtract. 74 minus 70 is going to be 4, and we're going to drop down this 2. 7 goes into 42 6 times. So in other words, we know 7.42 divided by 0.7 is 10.6. Okay, let's do one more example. And let's do something a little more challenging. Let's say I wanted you to do 12 divided by 0.25. Okay, so as I mentioned, you can never have the decimal on the outside of the bracket, so you have to move this decimal twice. When you move that one twice, you move this one, which is right here, twice, and add zeros accordingly. So this becomes 1200 divided by 25. Okay, so let's go ahead and work this out to see what we come up with. 25 doesn't go into 12, therefore we have to ask ourselves, how many times does 25 go into 120? 25 times 4 is 100, 25 times 5 is 125, so we know this is going to be 4. As I said, 25 times 4 is 100, subtract. 120 minus 120 minus 100 is 20. Then we drop down this 0, and the question now becomes, how many times does 25 go into 200? 25 goes into 100 4 times, so 25 goes into 200 8 times. 8 times 25 is 200. Subtract 200 minus 200, 0, so we can see there's no remainder. So we can see here that 12 divided by 0.25 is 48. So that's all I have for you for this video. If you found it helpful, please feel free to like the video and subscribe to my channel. In addition, go ahead and put some feedback in the comments section below. But on that note, I'm going to go ahead and cut you guys loose. Konnichiwa.